I think we should be live. I'm gonna pull up my phone real quick too. As you're rolling in though, say hello. And hopefully this stream is not gonna be too choppy or anything like that. Let me know if a lot of lag is coming up. I am traveling this week, which was not planned when I made the event originally. And then my microphone also wasn't working with StreamYard that I brought with me. So hopefully this won't be too chaotic, but there might be a little bit of things that come up since I'm on hotel Wi-Fi. There's a conference going on here, but hopefully it'll go pretty smooth. But again, let me know in the chat if it gets too choppy or anything like that or laggy. Let me know and I can try to switch over to my hotspot. I tested this just before this stream and it seemed okay, but just throwing that warning out there. I'll probably mention it again as more people join in. There's only a few people here already, but we're a couple minutes early. And I see Ronald said, greetings. How's it going? Oh, and it's also fun if you want to put in where you're watching from or streaming from. Or I'm streaming from San Francisco right now, but I'm based in Seattle. But I'm traveling on hotel Wi-Fi, like I was saying. Actually, so if anyone is in San Francisco, I'll probably mention this again later as well, and wants to grab coffee or something like that this week, let me know. Or if you have recommendations for San Francisco restaurants or cafes or anything like that, I would always be happy to hear them. I see people talking in the chat. Ronald and someone else said they're watching from the Bay Area. We'll see if more people join in here. Let me just double check that everything is live on Luma. But again, I guess is the streaming seems okay. I'm also only using the MacBook microphone today. Again, unfortunately, my other mic just wasn't working that I brought with me. And I'm, again, away from home. So I have some stuff going against me today. We'll get going here in a couple minutes since it's officially 1 o'clock now. Let me just make sure that Luma is pointing in the right place. Seems like people are here, though. And cool. See more people popping in. All right, people said it seems okay. Again, apologize if it's not. Only so much I can do. We're going to wait about just like 1 more minute for people to roll in because I see more people joining. But again, as you are watching, say hello in the chat if you haven't already. Where you're watching from is always fun to see. And then also, did you read the book or have you started reading the book or are you just here to listen in? Either way is okay. I know a lot of people don't read it yet and they come and kind of just listen to the conversation. And I'll mention this again as well later, but if you want to join the stream and actually come up here and talk like I'm talking, you don't even have to turn on your camera if you don't want to. You can message me on LinkedIn since there isn't really the DM feature in YouTube. Find me on LinkedIn and you can message me on there. So again, if you want to come up and be part of the live conversation up here, you can. I know a lot of people like to talk in the chat, and that's awesome too. I'll keep watching the chat, and I try to bring in interesting stuff from the chat in the discussion here. So hopefully you'll still feel like you're part of the discussion because that's the goal. And somebody said they read through chapter 4. Cool. All right, I'll get going through some of the slides. I saw a large chunk of people come in. So again, welcome. If you haven't come to the AI book club before, I'll talk a little bit about what we're up about. But this week we are reading and then discussing the Build a Reasoning Model from Scratch by Sebastian Raschka. That is the book for August 2026, which is this month. And we read a new book every month and discuss it online kind of in this format. And also there's a Slack channel I'll point to later, but if you want to discuss anything during the week, you can there as well. And this is a link to the book. If you haven't taken a look at it yet, totally recommend it. It was a really good book. His other book too, which we'll bring up and is brought up in the book itself, is Building a Large Language Model from Scratch. So if you're newer to LLMs, I think it's one of the best resources out there from any of the books that we've read that goes into the foundation of how a large language model is built, and you implement like tokenization and all that stuff from scratch. And then the reasoning model is almost kind of like a sequel to that in a way, where then you build a reasoning model from scratch. You don't go through building an LLM from scratch in here. You just do the reasoning part because it's already covered in this other book. There's a promo code for Manning if you happen to buy the book. You can also do it digitally through there. I don't get a kickback or anything from this. It's just a promo code if you happen to want it. You definitely don't have to use it. Then also, if you are reading on the O'Reilly platform, you can find it on there. One thing I bring up too is that a lot of public libraries and universities will give you access to the O'Reilly platform with like a library card. And I'm not, it's on there for me at least. Sometimes with the library one, it used to be a delay on newer books, but I think everything's in there now, so you can check this out. I know I had some friends who were using the Seattle Public Library version to read on there, so I always like to mention that as well. And then there's the GitHub repo as well. I'll share that in the chat. Sorry, I have an iPad with the chat window, and it's not it's kind of small, but I'm making it work. And then AI Book Club, like I'd mentioned, in short, we read a new book every month and then discuss online. You can also discuss during the week in this Slack group. There is a AI reading club channel. We've been talking about for a long time, but a little bit more seriously with a coworker actually, about doing an AI paper reading thing as well. So obviously papers come out all the time that are really interesting. We're thinking about some sort of format of discussing those. So if you have ideas for that too, also let us know in the Slack. I haven't updated the GitHub in a while, so the best way to find all the upcoming book clubs and everything is just on the Luma calendar. And then these are the books that we've read so far for this year. All of them have been really fun. This is, again, this month's reasoning model. Next month is vision language models. I'm really excited for this one. A quick note on that, if you go RCP for this right now, I might move it out a week because I think I'm going to be traveling that week again as well. And I'd rather, and if you weren't here at the beginning, I'm in a hotel right now. Hopefully it's okay. I'm streaming on the hotel Wi-Fi. I don't have my good microphone with me. So I apologize if the quality isn't at the bar that it's normally at, but I don't want to do that again if I can't help it next month. So I will be probably pushing that out 1 week or something like that. These are the books we read last year. And then what should we read next? So open for people to give recommendations if you have a specific book, or if you have a topic, we can try to find a book on the topic. Although some topics there aren't a ton of books on yet, like more cutting edge things like world models, etc. I haven't seen really a book go in depth on those. I really wanted to do evals for AI engineers soon, but I think it got delayed a little bit. So we have to see when it gets published. That's why I try not to make an event with the book until it's actually out, because they do get pushed out a couple months sometimes. Oh, someone said the link is no longer active. Let me just double check that real quick. Oh, might have to ping someone to fix it. I can message it out later as like a blast on Luma if it's not working. Oh, yeah. All right. Well, I will not try to fix that during the live stream. I apologize. I'll have someone fix that later. Oh, someone said go back to the screen, previous read. So we've actually done this for a few years now. This is the 2025 schedule. These are all really good too. I really liked, again, I mean, some of these get outdated probably a little bit fast right now, but the building LMs for production was one of my favorite intros to kind of building with LMs. It was really good. Again, it might be a little like there might be a better book now or slightly outdated. Deep learning for biology was really fun too. I like doing these kind of specific domain ones. Same with reinforcement learning for finance. The slides aren't available on GitHub. Good thing. Good shout out. Normally, I have them shared. Hang on 1 second. Let me just grab them for you. Anyone can view. Yeah, I usually do this beforehand. Yeah, another thing with me traveling is I'm actually at a conference right now. So I actually just ran up to do this. Normally I have a little prep time before the event. So might be a little more scattered, like I was saying. But those are the links to the slides. Somebody said, build an AI agent from scratch. That might be their next book. I don't know. On that note, about asking, if you were to ask the author, Sebastian, some questions, what would they be? I want you to think about it now and put them in the chat, because actually, I think he's going to come on an event with me next week. And what we're going to do is do it kind of as an author Q&A. So if you have any questions about this book or anything for Sebastian in general, let me know in that chat now, and I can go capture them. And then also, I haven't posted the event yet. We just worked out a time literally right before the stream. So I'm going to make that event, and I'll invite everyone. If you're on Luma here, you'll all get an invite later. It's going to be on Thursday next week. Hopefully you can join live, and then you can ask your questions directly in the chat. But if you send me questions now, I can try to log them and kind of prepare some questions for Sebastian ahead of time. So think about that. Are there any questions for the author? If you were reading the book, or as we go through any of the things we're going to discuss today, let me know in the chat, and we can log those for him later. And then one more thing before we get into the chapter content is I always like to do community shout outs. It's been really fun to have people to share, like, are you hiring? Are you looking for a job? Are there any awesome projects that you're working on or anything else you want to share? Feel free to put those in the chat as well. I know we've actually had people get interviews directly from it, especially sometimes when we've been reading a book in like a domain like biology or finance, and someone had just like majored in that, and then someone had been working in it for a while, and they were able to connect. And I don't know if they landed the job, but they actually got interviews set up for it. So want to leave that for a moment for anyone to share any awesome things. Again, if you're hiring, looking for a job, put in the chat. And again, questions for the author. Think about what they would be. All right, so normally I just kind of read out the chapters in order here, and then we can open up for discussion in the chat. And then we go through the chapters, and sometimes we'll spend more or less time on them. And it kind of has the sub chapters, so we can read kind of the highlights from it and then share your opinions if you have any on here. Somebody said they're a college student from Brazil looking for you're looking for an intern, or you're looking to do an internship? Okay, I think looking for an internship. And someone else is looking for internship. So if anyone's hiring for interns right now, check out the chat. I guess I used to do this on LinkedIn, so it might be harder to find you based on your YouTube channel. Maybe you have to share your name and how to find you on LinkedIn or something like that as well. Someone said, I'd like to know when Sebastian is going to teach his next online course. Is that the online course like he did with the LM from scratch? He did like a course through Manning that was kind of going through stuff around LM from scratch, or is that a different online course? Oh, cool. And someone shared on LinkedIn, looking for internship from SJSU. All right. So I'm going to read through the chapters real quick here. And then again, put in, I guess, if you've read the book, or even if you haven't read the book, you could put in the chat too, like which ones of these were the most interesting to you, or what sounds the most interesting, even if you haven't read the book, kind of the themes of here. So chapter one was understanding reasoning models. So again, we'll break this down a little bit, but goes into what kind of reasoning is when it comes to like large language models. And then chapter 2 is generating text with a pre-trained LLM. So like I was saying, the first book, I don't know if it's officially a series, but his previous book, The Building a Large Language Model from Scratch, which is really, really good. Totally recommend reading that if you haven't. That goes into building it from scratch. This one goes by importing a Quinn model. I forget the exact size. I have it in my notes, I think, but blanking on which exact size it was, like a small Quinn model that you can usually run on a lot of laptops. And then you generate text with that already trained large language model. And again, the reason is in here, we're taking a pre-built model and then we're going to add reasoning to it. So you don't build the actual LM from scratch in here, you build the reasoning portion. And then 3 is evaluating reasoning models. So kind of important to, one, add any capabilities and know how they're doing. Having some sort of evaluation is very important when you're doing something like reinforcement learning. And we'll talk about this later, but something like reinforcement learning with verified rewards, where it can kind of auto learn if it's doing the right step or not without human feedback. It's obviously very important to have some sort of evaluation in there. And that's what this chapter is about, is building it. They build it on a math data set. And then math and code is great because you can actually see if the results actually match up to something, right? Like they're kind of easier to evaluate than some problems. Like if you're working in the science space, that could be a little bit harder, right? Using reinforcement learning with verified rewards gets a lot harder. And I think that's why we see so much good progress right now in coding and stuff, is it's actually easy to reward and train these models based on it. And then we had chapter 4, improving reasoning with inference-time scaling. And then we have chapter 5, inference-time scaling versus self-refinement. And so these, the part of these like chapters, or almost like part of the thesis of the book, is that you can, like, if you're training a model from scratch, or not from scratch, but you're adding this like reasoning layer, and you want to get your results, you can kind of pay upfront costs for training that model for reasoning, which can take a lot of time and resources potentially. Or at inference time, you can probably get to the result that you're looking for by doing a whole bunch of different things. And again, we'll break this out when we get to the other chapters. But like, for example, you might do chain of thought reasoning. You might have already put that in a prompt before, and you can see that now the model kind of outputs more tokens, and it gets to go through more compute loops, and it can kind of maybe reflect on what it was thinking and then get to the result potentially. Or at inference time, you might just try more variations. So like they go pretty in depth into temperature in here and how that varies the model output. And so if you weren't getting the right result, right, you can adjust the prompt, or you can adjust the selection and temperature of how your model generates responses. And so that's how you can kind of scale this up with at inference time and hopefully get to the right result. And then chapter 5 is inference time scaling via self-refinement. And then we have chapter 6, training reasoning models with reinforcement learning. So this gets into the first kind of RL part, and it introduces GRPO, which is gradient. Wow, what was it? Gradient. I'm blanking on what it stands for right now too. Something policy, right? We'll come back to the exact thing that it stands for here in a second. But this is the policy that I think originally came out of like the DeepSeek paper. And it's a little bit different way of doing reinforcement learning. Like if you've ever done PPO before, GRPO gets rid of a secondary model that makes it a lot lighter weight to add reinforcement learning to something like a large language model, where it'd be hard to keep track of both of those states. And then chapter 8 goes into distilling reasoning models for efficient reasoning. So the part of this is that you could actually take a larger, already well-trained model, like a larger model that's trained to do reasoning, and then distill those outputs into a new, smaller model. Distilling's been around for a long time. You've probably seen or used models before where they're trained on outputs from a larger model, but you train a smaller model with those outputs, and you can often get pretty good results from it. So it's just another way of basically that you can maybe add in this reasoning to a smaller language model. And I saw a lot going on in chat, so let me just grab up here, grab the chat here. Group relative policy optimization. Yeah, I'm pretty sure that's it. Group relative, as everyone corrected me. Group relative. Somebody said, I thought the most interesting was the discussion about trading speed and computational costs for accuracy. Wondering if GPU progress will solve the problem. Who knows? Just catching up on chat. If there's anything else in here. And that was the course that people were talking about. Was Sebastian did a really good course that was around the other book that was kind of supplementary to it too. So it wasn't just reading the other book, it was stuff around the chapter is really good. He might do that with this, I'm not sure, but that'd be a good question to ask. So again, if you just joined, Sebastian's probably going to join a stream next week, next Thursday. So if you have questions for the author of this book, let me know, and I can format that into questions that we can ask live next week. But also, again, you'll get an invite because I don't have it posted yet, but join the stream live and you can also ask those questions. All right, so after reading these out, I think some people mentioned some of the interesting chapters. Were there any other ones that people thought were super interesting? And the book is nice. One thing I mentioned too, the printing of this book is awesome. If you order, at least through Manny, and I saw some people are getting like counterfeit ones if you order through Amazon, but the physical book of this actually has really nice color printing. And again, I don't have it with me because I'm traveling this week, I was hoping to show it off in stream, but it's definitely worth getting if you like physical books. And sometimes with the printing for technical books, they have like really nice charts, and you read them digitally, and then you go to the printed version, and it's not nearly as nice. But this one's actually just super nice. All right, so we can go in, maybe break down chapter 1 a tiny bit, which again is defining reasoning in the context of LLMs. Or sorry, so these are like kind of subchapters in there. And we could also potentially bring up the code repo a little bit at some point. So I don't show the book. If you're new here, people are like, why don't you read the entire book? That's not really what a book club usually is, a discussion around it. And I also don't want to show the actual book. I don't own any copyrights or anything to it. So I'm just going to kind of read highlights of the like sub chapters and then discuss those and read off the chat. And then again, also, if you want to join live and you want to come on stream, message me on LinkedIn if you happen to want to come up and discuss anything here. But you're also welcome to just keep talking in the stream. So chapter 1 was, again, defining, understand reasoning models. So we had defining reasoning in the context of LLMs, understanding the standard LLM training pipeline, improving LLM reasoning with training and inference techniques, pattern matching versus logical reasoning. Again, I mentioned, reasoning in the terms of LLMs might be a little bit different or is different than like reasoning when it comes to humans. So you're kind of doing this kind of pattern matching reasoning that can work and get your LM to have better results, but it's not really necessarily the same as you doing like human reasoning. Simulating reasoning without explicit rules, why build reasoning models from scratch, and then a roadmap to building reasoning models from scratch, which just goes through like the upcoming chapters. And like I was saying, just ran up from the conference, not quite as prepared this week with going through the chapters super fresh in my brain. So I have to kind of look at this again too to see what jumped out. Any notes that people wanted to shout out for in this chapter 1? Again, I think I mentioned this before, but this kind of sets up the at least how I kind of view it is like that you can spend compute at the training time, like to get those reasoning results that will hopefully get the answers that you want. Or you can spend the training time at inference, or sorry, the training cost at inference time to maybe get to the same thing. But again, you're going to be doing more variations, more temperature sampling, and potentially prompting to get to that result. And then chapter 2, we had introducing LMs for text generation. Again, this sets up the Quinn model that they are using in here. A little bit about setting up your coding environment, understanding the hardware needs and recommendations. If anyone has a GPU or anything, you shouldn't have to worry about this, but he usually makes his book so that almost anybody can run them on most hardware, which is awesome. So by default, a lot of the code also uses like CPU, and you have to uncomment something for it to work on GPU. Preparing input text for LM. So it does go into a little bit about tokenization, what it looks like. Again, if you want to go way deeper, recommend his previous book, the Building Large Language Models from Scratch. It shows how to load a pre-trained model, like from Hugging Face. Understanding sequential LM text generation process. So again, right, you're generating a token, like, or a word and a token, and then you're basically always just predicting the next word that's coming after there. Coding a minimal text generation function. So again, this is from scratch. So even though it's not building all the features for an LM from scratch, you're building this out. So coding a minimal text generation function that uses that LM and then generates text and streams it out. Faster inference via KV caching, and faster inference via PyTorch model compilation. PyTorch has a lot of really cool stuff now for compiling, if you haven't looked at it. One of the earlier books we read was the AI system performance engineering, which goes way deeper into it. But there's a lot of really cool stuff in one of the PyTorch 2 releases for profiling, like your PyTorch environment for your model and then compiling it, which can really speed up your work. Somebody said they're brand new to this. What's the difference between an LM and a reasoning model for LM? Which is a good question. So that's what this book really goes into. But the reasoning LM, there's kind of different ways where you can generate tokens. You're still generating tokens, but it's doing it in a way where it adds, like if you do a chain of thought, I don't know if you've ever looked at like a chain of thought process for a large language model, but instead of just getting directly to the answer, it tries to kind of reason or think about it. And if you've used one of the newer like Claude models or one of the OpenAI models, like what's the one where reasoning came in? Was it O? I forget which version it is, but when you use a large language model and you see it doing like thinking, where it's like, let me think about that before I really answer it. That's kind of the reasoning step. So it's kind of looking and generating text and kind of, again, for the lack of a better word, of reasoning. Like I was saying, reasoning is different than like logical reason from a human, but it generates output or like next tokens that can add context, I guess, in a way to get to the answer. And sometimes it'll add something and go, oh, that's not right. Let me correct that. So it adds this extra layer of like thinking before answering, basically. Even though it's generating before answering and using that as like context to hopefully get a more correct answer. Is how I would kind of summarize it. But if somebody else has a better kind of like couple sentence summarization, put it in the chat. Or again, if you want to come up on stream, message me and I'll send you an invite link. But for the person who asked that, Jimmy, if you you've probably used a reasoning model without realizing it. And a lot of the open source models now have reasoning built in too, and you can often even enable or disable it on generation time. So sometimes you'll see like a thinking token be generated, and you can enable or disable that. Does anyone remember why he uses base Quinn and not the instruct tune one? My guess is to show it and prove, probably, versus the instruct one. So if you're actually putting something in production, you might want to use the instruct one. But if you want to take the base one, maybe the base one didn't have any like reasoning in there yet, probably. You probably see quite a big improvement versus the instruct one. It's my guess. Somebody said build a large language model from scratch is from a couple of years ago. Is it still recommended? I think so. I mean, I don't think the transformer architecture for LMs has changed that much. Besides, now you have things like reasoning, and that's why this is a good like secondary part to that book. If you're looking for in depth on large language models and like how they're built under the hood, I think the LM from scratch is really good. And again, it's not about putting something in production. It's about what's under the hood of large language models. So I think books like that are going to outdate a lot less fast too, because it's not about one specific tool. It's about you building something from scratch and understanding like when you're using Hugging Face transformers and PyTorch, what is actually going on underneath the scene. So again, it depends on what you're looking to learn. I think it's really good if you're trying to understand how a large language model is actually built and working. Somebody said, I thought the reason was, because we're duplicating functionality found in the instruct one. Yeah, so I think that's if you do the instruct one, does instruct have reasoning? I think it does, right? So I think the base one, because the base one doesn't have any instructions, and that could be the reasoning side, but also the just how to answer question side. And then this is about adding reasoning with reinforcement learning. Otherwise, you could probably adjust like how it reasons, but yeah, you wouldn't get to see it from scratch, I guess. And someone else also said the same thing. Build a large language model from scratch is awesome and still very much recommended. And they said, think they'll pick it up. I have one. Again, I don't get kickbacks or anything, but there's a promo code. You might find a better one. This one will give you 45% off. Sometimes if I just go to Manning, there's a better code in there, like by default. Oh yeah. That person or someone said they can take a cut at explaining reasoning models. Which, do you want to join the stream? If you want to join the stream and explain it on here live, you can send me a message on LinkedIn and I will send you a link to join live. Catch you on chat. Sorry, there's a lot going on here, which is great. So just making sure I'm getting everything though. Someone said it doesn't reason. Oh, I think that was back to the base model. So yeah, the Quinn one, I guess, has the thinking reasoning in, and then we're replicating it here. And like I said, also bigger effect. So yeah, I wasn't sure if the base one, it makes sense. It would have thinking. I think all the Quinn models do have thinking now. So I was even thinking just from the instruction side, but yeah, if it has a thinking token, then we're replicating it. I should have a link that I shared in the chat. So someone's asking about how to join the stream. If you message me, I should have shared a link and I'm keeping an eye out. Okay, cool. Let me send you this link real quick. And because I don't have my separate microphone with me, I'm going to go on mute as you're explaining. So hopefully there's no feedback, but we'll see if Ram can join. I just sent you the link. And it's always more fun when I feel like other people are up here discussing, adding their explanations. Obviously, some people can explain way better. They also said, somebody said they love the Python code snippets to get up and running quickly, and the instructions for both NVIDIA GPUs and AWS. Yeah, and a lot of times, again, you can run a lot of this on a CPU too, or like if you have a good MacBook. And somebody said they have old NVIDIA GPU, so they plan to implement as much of Sebastian's code as possible using GPU acceleration. Again, most of it, they just have something you need to uncomment, and you should be able to run it on most GPUs, or like an NVIDIA GPU if you have CUDA enabled. All right, so chapter 3 is great. A lot of discussion happening. Awesome. Chapter 3 was evaluating reasoning models. So again, building a verifier that we can start using for the. I mean, you can actually look at it and see it's verified, but later on when we get to reinforcement learning with verified rewards too, this makes it way easier to kind of do the self-improving and see how it's doing and then adjust weights. We have building a math verifier, loading a pre-trained model to generate text, implementing a wrapper for easier text generation, extracting the final answer box, normalizing the extracted answer, verifying mathematical equivalence, grading answers, loading the evaluation data set, and then evaluating the model. Again, also, I'll share this again for people who were talking about it. You can find the GitHub link here, and actually, we could probably bring up, let me just see real quick what's in here. I haven't run all the code, so sometimes when I read these books, I'll read them and I skim through the code in the book, but I haven't actually run everything yet in all the chapters here. So I'm not actually familiar with how it's even laid out, besides from reading it in the book, but I haven't gone through and like run the notebooks. But you could go in here and find all the code and walk through. Oh yeah, so they use the 0.6 billion Quinn model, which again can run on quite a bit of hardware. So not every piece of hardware, but quite a bit. It's probably the smallest LM where you can actually get reasoning to happen. Even one of the times I was using a small model, maybe it was an earlier version of Quinn, and I was trying to add in some RL stuff, and Part of reinforcement learning actually is a good thing to keep in mind. If you've done RLO, you probably already know this, or maybe it's a good reminder. To do reinforcement learning, you need that model to be able to do the thing that you want to reinforce sometimes. So if you have too small of a model and you're asking for it to do something pretty complex, it's not going to get there because it just won't do the right thing to get positive rewards for it. So just something to keep in mind, like this book, again, from scratch, you're using this really small model, but if you're trying to reinforce a large language model to do better at coding through GRPO or something like that, then you have to have something that can actually complete the code that you're giving it, so you can give it like rewards. Otherwise, if it never gets there, it's never going to get positive rewards and go in the direction that you want. So I had that sometimes where I was like, oh man, I'm never getting this. And it's because you have to increase the model sometimes, or increase the model size or adjust your prompts or whatever in order to actually get the generations that you want to reinforce. Somebody asked what's your preferred AI. I think it depends on what you're doing. I've been using Claude Code right now for a lot of the coding stuff, but I mean, Codex seems really good. Seems like every other day somebody says the other one's better or whatever. So curious what other people are using. Oh, and somebody brought up Apple. Apple start. Oh, Ram's here. Sorry, I missed you joining. Hello.
Hey, no worries. I was waiting patiently.
My apologies. Like I said, usually I put phones in, and I did not today. So I'm gonna go on mute if you want to explain your take on reasoning models.
So yeah, I was actually doing a write-up on this, which I hope to get out hopefully this week. But there's been some research that shows. So I'm not going to try to explain the mechanism, but just sort of analogy of what's happening in a reasoning model, if that's useful. You think that? Okay. So there's research that shows that like these large language models and actually the state space models are basically functionally equivalent to Bayesian inference. So if you think about the state of the knowledge that's encoded in a model as a geometry or a set of possible geometries. So when you're using a normal model, a non-reasoning model, and you put in a query, it's attempting to navigate the space, the geometry, in one shot, in essence, right? Just trying to go from where you're starting the model at to an endpoint. It's trying to navigate the entire the possible geometries to find the most relevant solution based off of the information that it has at hand that you've provided to it, or that's been provided to it. And with a reasoning model, what it's attempted to do is, use something like chain of thought. That doesn't make the model smarter, quote unquote smarter. What it's trying to do is it's trying to break the request down into smaller constituent parts. And so it's trying to traverse the geometry of the model, of the knowledge base in increments to avoid traps, to avoid local minima. So it's trying to avoid like high entropy chasms. If you think about it like energy states, it's trying to avoid chasms and decompose into paths, low entropy paths to get through the space to get to the best solution. So the analogy is to think about it sort of like if you're looking at a map and you're trying to go from point A to point B and you're not quite sure where point B is. So you, instead of trying to do it in a single path, you find waypoints along the way that lead you closer to the end. And then if you find you hit a local minima, then you're able to back out and go a different path. So I don't know if that's helpful, but that's the way I kind of think about it.
I like it a lot. That's great. That's why, like, even like you're saying, adding a couple of years ago in the same book club, we were all playing around with Elms for the first time, and it's like, wow, it's wild. Like chain of thought, right, can really improve something. because I guess I hadn't even mapped to like the I like your way of like you visualizing it with the local minima getting out of that, right?
Getting out of it, right? Being able to back out of it or try to jump to a next maxima, or to a better maxima.
And I was seeing in this chapter they had visualizations around. I was thinking if there was something that would be helpful in this chapter, because they show stuff around just like next token prediction type of stuff. This is like the chart where it's predicting like a next word in here, and it might not be in this one, but at least in the book, maybe it's a separate visualization. But they have like adjusting the temperature of getting more creative in different tokens. And so like, again, if you get a token result, I guess, for your reasoning, but it's not the right one and you want to go to another one, like how do you do that? I was seeing if there was a good visual for kind of what you were talking about in here. Did you happen to read the book?
I started and didn't have enough time to finish.
Yeah, no worries.
Yeah. I'm skimming it through it really quick now.
Yeah. Sometimes what I'll do too is like I always try to read the book. Sometimes I read it faster, and like there'll be parts where I'll skim through if I need to before the book club, because I have to be up here and talk about it a little bit. But I will go back to really good ones too, and then it's kind of nice to it's there and you can go back and reference it, or just read through it a little bit slower next time. So and no one has to finish it like right at the book club meeting or anything like that. And someone asked to share this GitHub link again. Share the GitHub link in the chat. But it's a cool book. Any other thoughts on reasoning models while you're up here?
No, I mean, nothing that comes to mind just yet. Maybe something will pop in. I think part of the reason why I enjoyed this book, even though I just sort of skimmed it, and the other book, Large Language Models, because I think it's super interesting to understand how, even if you're not going to actually build one, just like to understand what's going on underneath the covers. Yeah, I like to understand what's going on, not just use things blindly.
Right. Like under the hood, why is it doing that?
Yeah. How's it doing the thing it's doing? Which
really helps you use it hopefully in production, or understand why you get the result.
Yeah. And also like where the weaknesses are, like, what not to expect it to be able to do.
Right. Like don't expect it to necessarily be the best thing.
Don't expect it to actually do reasosoning.
Yeah, exactly. Yeah. I think the book opens with that. It's like this is what I mean by reasoning in this book is like how we're defining reasoning models right now. But like you were saying, it's generating. It's really just generating more text and using that as to hopefully get to the result.
Yeah, I mean, if you look at the like the output of reasoning models, I'm running reasoning models locally on my own DGX Spark equivalent, basically. And so like, I can turn it on and off and kind of dive into stuff. And when you look at like what the reasoning model is doing, a lot of times it's burning tokens to just remind itself of what you're asking it to do, right? Yeah. What it was originally asked to do is like, oh yeah, I need to stay on track. Like, I'm about to go off track, right? So it's not really reasoning. It's sort of just like trying to keep its context clear. Yeah.
It's reinforcing where it should be going in a way.
Right.
Which I've noticed that too with I also have a DGX Spark and like running local models in there, and I always display the thinking tokens anytime I'm running something in there. And just like you're saying, it'll be like sometimes it goes off the rails, and then it's like, oh, but that's not what the user asked for. Let me bring it back now. Yeah. Like, this is actually something completely different. Yeah. Yeah, so it's really, really funny to see. I'll quickly go through the other chapter list here, because I have a hard stop around 2 as well, because I gotta go back to the conference, which is great. I love it when we don't get through all the chapters, even, because that means there's good discussion happening, which is awesome. But the we were on chapter 3, I think, before, which I think I saw some people in the chat too, like how they were like, I always heard evals were, hard to do, and then you didn't really think about it as much or something until they read this chapter. Which again, if you are working like literally at a keynote that I was at this morning, and they were giving a talk, and they work in sciences, and they brought up reinforcement learning with verified rewards, which again is something you can do with like coding and math. But if you're doing something in a more creative field or in science, which I guess should have a result that you can verify in theory in some ways, but that's much, much harder than doing something like a math problem. And there's probably a lot of experimentation and stuff like that goes into it. It becomes a really hard problem. So like evaluating is just something you really need to do for if you're doing something like RL especially, but even just anything in production, having good evals, not even just on a model, but like a whole system, is going to give you a lot of value. Four was improving reasoning with inference-time scaling. We talked about it a little bit before. I'm going to go a little faster through these, and we can get to the end and then come back to any of the ones. But Ram, if you have a thought on anything too, feel free to bring it up. Chapter 4, improving reasoning models with inference-time scaling. Introduction to inference-time scaling, loading a pre-trained model. So this is a chapter I had up a little bit ago in the GitHub where it showed like predicting the next token. So you can adjust things like temperature in there. Generating better responses with chain of thought prompting. So we mentioned how you can add this in, and it gives you a little bit of the features of like it can try to generate how it's getting to that point. And then again, if you think about how an LM works, where it's always generating the next token after another, it can kind of add a little bit, I guess. Again, I like the way you described it of almost like noise, but also regrounding of like where it's going to hopefully get there. Controlling output diversity with temperature scaling. And I accidentally left in a show more items clip there. And then balancing diversity with occurrence with top T sampling. So again, the temperature scaling is like how people often use the term like how creative your model is. But the term is like when we looked at that graph I had up, I don't think I have it up anymore. And it was like the next token for the capital of Germany should be Berlin, but you can adjust the temperature so that that's not as high, and it can choose some other words in there. And so when you're doing something like reinforcement learning, like the other chapters go into, you actually want to often adjust your creativity scale so that you get different results on the different rollouts, and then you can reward the correct behavior. So if you're just doing the same result over and over again, you're not really sampling the top different kind of choices that the LM could make, and you're doing reinforcement learning, you're not really going to learn a lot from it. So you want to add in this kind of a temperature control when you're doing a whole bunch of rollouts.
I'm curious, so I haven't used the hosted frontier models much recently. I should probably dive into it, look at it again. But I heard that they were taking away a lot of those controls, so it's actually harder or impossible now to adjust temperature and other settings to get the variance that one might want, or to remove variance where one wants to do that.
Good question. In terms of the chat interface, I haven't looked. I don't recall seeing one recently. It totally might be there, and I just haven't felt like I needed to tinker with it. But I think of the APIs, hopefully that's still available. Like it was last time I used it. I imagine it would be. It would almost seem crazy. I guess I haven't tried like newer Fable model through an API or something like that. It would blow my mind if you couldn't do something like that.
Yeah, it seemed terrible. Maybe somebody has done that. Can chime in.
Yeah, if anyone has used it recently with temperature, or you've noticed that temperature isn't there, put it in the chat. That would be super interesting. And someone also said thank you, Ram, for your explanation in the chat. It was great. I love it when people come up here. Chapter 5, inference-time scaling via self-refinement. This is scoring and iteratively improving model responses, loading a pre-trained model, scoring LM responses with rule-based score, understanding token probability scores, from token probability scores to log probability. So I think that actually chapter 5 might have had that chart that I was thinking of, or built on chapter 4, and then you can look at the next token predictions and then adjust that. Self-refinement through iterative feedback, coding the self-refinement loop. So you kind of put this refinement loop together. And then chapter 6 is training reasoning models with reinforcement learning. It's kind of the introduction to RL for LMs. And then the reinforcement learning verified rewards using GRPO, loading a pre-trained model, loading a math training subset, sampling your rollouts, calculating rewards. And again, we can come back to some of this. I'm just going to go through the chapters and then come back in the last 10 minutes that we'll have. Preparing learning signals from rollouts via advantages, scoring rollouts with sequence log probabilities from advantages to policy updates via the GRPO loss. Putting everything together in a single GRPO function, implementing the GRPO training loop, loading, evaluating saved model checkpoints. And I think we'll come back to this chapter. The GRPO stuff is pretty interesting if you haven't looked like at how that works. Chapter 7 improves on that. So you're basically implementing some of the stuff that I think is, even from my recollection in the GRPO paper, but I think they simplified it to introduce it, and then they add in stuff that makes it a little bit better here. Improving GRPO, tracking GRPO performance metrics, tracking more advanced GRPO performance metrics, stabilizing sequence level GRPO using clipped policy ratio. So like the clipping and the KL term, I think were ones that were in the DeepSeek paper. And then adding explicit format reward. It feels weird when I say the word GRPO like a billion times in a row. And then chapter 8 was distilling reasoning models for efficient reasoning. I mentioned at the beginning, so like adding building you could build a smaller large language model using a bigger one, getting results from it, and then distilling and getting some of the results, in this case, like reasoning from it. So introduction to model distillation for reasoning tasks, generated data set for reasoning distillation, loading the math training data set for distillation, building training examples, loading a pre-trained model, computing the training and validation loss, implementing the training loop for distillation, evaluating the distilled model, future directions for reasoning models, and then the conclusions of the book. So super fast through the last several chapters here, but I assume we probably want to go back to some of the GRPO stuff. But if anything else resonated for people that we should talk about in the last 10 minutes here, let me know. And then just a reminder, next week, we're going to be doing the event with the author on Thursday. So you can count that as almost a second book club for this one. And we can come back and discuss anything else that we didn't yet, probably during that as well. And I'm going to catch up on chat. I don't know if you had anything else that really stuck out, or anything you want to call out in the other chapters.
Me? I think like actually the one that I'm probably going to dive into, hopefully between now and Thursday, is chapter 3, evaluating reasoning models. I think that's probably the one that is most relevant to most people in sort of their everyday life, like trying to figure out which model to use, given all the choices. So.
Ronald just literally blew my mind. Well, not literally, but but you did blow my mind. Prepare to have your mind blown. It's true that you cannot adjust temps on Opus and higher.
That's what I thought.
Wow.
Yeah, I thought they'd remove that from Opus. Yep.
Yeah, OpenAI you still can, I think, right? I've used more of the OpenAI API, but I might be on an older model because I haven't needed like the latest one for some of the API stuff that I was working on.
Yeah.
That's interesting.
They're trying to lock it down because they're trying to get more reliable outputs, I guess, or less variance in the outputs for the users. But
you would want that if you're developing from an API, right? Like,
yeah.
Why even let us select a model?
Yeah.
that might be the next thing coming, right?
That's probably the next thing. I mean, that's again all the more reason to have sovereign AI, right? So you have more control over.
Yeah, I'm curious. Like that's interesting. I need to go read like people's comments on that. Somebody asked, can you recommend a book for going deeper in RL for LMs? They read Sutton. That's like the classic reinforcement learning book, and did some of that, but not LM or even deep RL. So there's actually, I'll bring this up while you're here, or while people are here, because I was actually thinking, so we have the vision language model in September. October, I was thinking about doing a separate reinforcement learning book that goes a little bit deeper into reinforcement learning in general. And I was looking at the grokking one. It looked pretty good and not like crazy dense. Like the Sutton one reads more like a textbook. There's a series called Grokking, which is also a Manning series. And it's like, they're way more shorter and like a really good intro to topics. So that one, Grokking RL, it's from 2020. Almost every reinforcement learning book, I swear, is from 2020. But now reinforcement learning has really come back, so I'm sure we'll see a resurgence in books. But then there is a new one that just came out this month or last month that's called Reinforcement Learning with Human Feedback, that goes deep into like doing RL for LLMs. And I was wondering, actually, it's fun that someone else brought this up, if that would be like what other people would want to go into for the next couple books. Do like basically an intro to RL and then build on that with the RLHF kind of book. I think would be kind of fun.
Yeah, I think so.
Yeah.
There's another one. I don't know if it's in your list. I haven't read this yet. It's in my pile of books to read. Multi-agent reinforcement learning by Albrecht, Christianos, and Schaefer.
Multi-agent RL.
That's from 2024, but
cool.
It's an MIT Press book.
Maybe that'll be December. We'll do a whole reinforcement learning quarter. And a lot of comments people are like, why wouldn't they let us adjust temperature? There's a fun can of worms. I'm gonna have to go read about that later.
Yeah, they're protecting you from yourself.
Yeah, and someone asked me a book recommendation for RL. I don't have one, because I mean there's the classic ones like the Sutton one. The Grokking one looks good. I haven't read it yet.
Yeah,
so we'll read it in October. But that's again a pretty condensed one. I've gone through like a course a while ago, but book wise I'm not 100% sure. So we'll find out, I guess, next month, or the month after, I should say. Just catching up on chat again. Someone else said that would be awesome. I think that's about the RL books. Somebody else said that sounds cool. Would also be interested in Sebastian's other from scratch book. What was his other one? The LM one, which we read in the book club last year, or actually it was technically the year before. It was the December. It was really good. But I know he's done a couple other books, but I haven't read them either. I think someone else commented he's been on like No Starch Press and Pact, and then now he has this Manning series, which I think are doing really, really, really very good. So also, again, think of questions. If you have questions for Sebastian, let me know what they would be, and then we can ask them later. We have the last 5 minutes. Anything else that people want to bring up? Again, I know we kind of really slammed through the last few chapters here. If you haven't read it yet, totally recommend reading it. If you want to discuss this, I know the Slack link was broken. I'll fix that and send out, I guess, a blast probably on Luma if people want to join there. You don't have to, but there's a channel, the AI Reading Club channel. So if you do want to discuss things like throughout the week, or as you come back and catch up on the book, it's a fun place to do it. Yeah, any other last thoughts people have on this book? Again, think of questions, read it if you haven't by next week, or read more. I'm going to go through some parts again by next week, and then we can almost treat the Sebastian's meetup as a secondary book club thing for this.
Just cool.
Catch up on chat. Yeah, intro to RL. There's a lot of other chatter in there. People are saying thank you. It said Sebastian has a book from Pacton Machine Learning 3rd edition and a book from No Starch on machine learning, Q and AI. I'll have to look up his other ones. I know his last Manning one and this one. I haven't read his other ones, but I'm sure they're very good. He seems like a great author. If you don't already follow him, you should follow him wherever you like going, like on Twitter or on LinkedIn, or he has a Substack. He posts really, really good stuff. Definitely one of my favorite kind of like researchers to follow.
For sure. Yep.
Well, I guess I got to wrap up here in 3 minutes. Anything else people want to quickly discuss? Any other insights you want to provide while you're up here, Ram?
No, just want to thank you for doing this, and This is I look forward to these every time
Awesome.
I come
Yeah.
up. Try to
Thank you so much for coming up.
Yeah, appreciate it.
And if you have ideas for books or anything like that, let me know. Also, you're always welcome to come up. I'll message you later, but I'm happy to add you to the invite. So you don't have to come up every month, but you'll always have the invite link if you want to.
Oh, cool. Yeah, appreciate that. Thanks. I'll only come up when I have something interesting to say.
Yeah. No pressure. It's just, you're always welcome.
Hopefully interesting to say.
Yeah. All right. I got to wrap up the stream because I got to literally head back on the conference.
Which conference are you at?
I'm at Ray Summit in San Francisco.
Okay, cool.
Yeah. So if anyone is in San Francisco and wants to get coffee or something like that later, I'm here I leave on Thursday evening. Pretty busy Thursday, so now through Wednesday, really.
All right.
All right. Thank you again. I'll talk to you later. Bye.
Bye.
Thanks again, everyone. I'm gonna wrap up. People are saying thank you. Yeah, if you have San Francisco recommendations, let me know too. Someone said burritos. Obviously, I already had one. That was literally when I got here right away. Got that. Yeah, we didn't get to some of the meat of the GRPO stuff, which I wanted to. Again, I think it's a good problem when we ran out of time, because it usually means there's good discussion happening. So again, maybe we'll come back to this on the next meeting as well. You can also dive into the subject a little bit by yourself and discuss it later. So all right, I gotta head out, so I will talk to you. Waymo trip, I have done, not this trip, but I have done Waymo before. I took my dad in one too, and I'm hoping to maybe get my mom in one this time. And I want to see, it's fun to seeing their reactions. All right, I'll talk to you later.